Now, next is a person that I've worked with for quite a while. I've been very impressed with his work. I'm sure you will be too. Barry Starkey from Northgate Public Services. He's been working with Oracle technology for a number of years. In fact, used to work at Oracle a long time ago. We did not, as I remember, cross paths, but I've worked with him for a little while now, and I've always been impressed by what he does. He's been using a range of Oracle technologies, but most recently has been using Oracle machine learning. I guess I'll just let him take it away from here and show you what he's been doing. And you can also, what I like about what Barry's doing is it's all sort of live and interactive. So probably some things will break. We think that's the fun of these TechCast. It's real. So take it away, Barry.
That's great. Thanks, Charlie.
Stop sharing.
Yeah, I shall start sharing my screen. Here, 1 second.
Hello.
Here we go. Hi.
You have to give a little expose on where you're sitting as well.
well, just before I'm sitting in the engine room of the Kroll from that famous 1950s film with Leslie Nielsen, The Forbidden Planet. And you might see another reference to it in a minute. So.
Very good. Loved everything that Leslie Nielsen did. For those of you who remember him, I loved him.
Fantastic. Right, here we go. I'm sharing. Okay. Hopefully you can all see my screen.
Yeah,
okay.
Looks perfect.
Right. When I was asked to do this, I decided that I wanted to show how we can use the autonomous data warehouse and cloud and the analytics cloud and basically my journey from SQL developer, data miner through to that, just as this slide suggests. But I thought I'd do it by creating one model. The model I'm going to show you is all about, will the tenant pay next month's rent? This is just one of the many models I've designed, and I'm only showing you the very start of the process of this. This isn't the finished. This will not be the finished model, but I'm going to show you how we can use the Oracle tools to get a better idea of how the model works and how to design the model and get there quickly. So if you imagine you're looking after 30,000 properties, and you haven't got a lot of money to run your teams, you need to find the tenants that are going to be struggling in the coming months. And you need to find them in amongst those 30,000. We can't afford to phone every single one of them. So how are we going to find the people who in 5 weeks' time are going to start getting into trouble? Well, machine learning, of course. We can, and my background has been using SQL Developer and Data Miner, and why? Because it's a point-and-click interface, as I've said. It's pretty easy to use. You don't need to know anything about the underlying code and commands that you use. So it's just a great tool. It's been there a long, long time. But if we're going to move to the cloud, we need to understand what it's generating behind the scenes. So, and Charlie wanted me to say this: the Oracle Cloud Machine Learning Zeppelin notebooks, which we're going to see in a moment, they have a brilliant example section which will help you. But I'm going to take you through my journey from the GUI in SQL Developer. So here it is. This isn't a live demo. What we're going to do, we're going to create a very simple. We're going to create a very simple binary classification. Will they pay? Won't they pay? So we need a data source. And here I've got two tables. I've got an 80-20 split.
Hey, Barry?
Yeah?
Barry, just to clarify, will they pay within a certain window of time or something, right?
Yeah, it's very specific. One of the things about classifications, you really have to be specific. And the specific question is, will they pay 4 weeks worth of their rent in 5 weeks' time? It's a very specific question.
Perfect.
Now, and I'm using 5 weeks because people pay at the very start of a month, and then at every start of the month, or they might pay on the Monday of the start of every month. There's always a chance that we're going to sneak into 5 weeks. So that's why That's why we're looking at 5 weeks. And I've pre-split the data into 80% and 20% because I want to make sure, and I know you can do that automatically in Data Miner, but I want to do that to make sure that there isn't any data in my holdback set, my 20%, that belongs to tenants that are in my 80% set. I have to be very careful with that. So we pick our two data sets. So what do we need to do now? Well, we need to get a model. So we're going to do a classification model. So we drop that down on the canvas, and then we connect the 80% set to the model. Now, for the purposes of this demonstration, I'm only going to deal with decision trees. The interesting thing here is the decision tree is one of the best models, the most open models for explaining to the end user why we came to the decisions we came. It's not a black box model. In Data Miner, we've got we can use these other algorithms, the naive Bayes, the support vector machine, the generalized linear model. At 18C, we've got random forest, and we've also got neural nets, but we can't get to them easily from this GUI. So for the moment, I'm going to reduce this just down to the decision tree. I need a target that happens to be called the RTS objective in this case, and that's either a yes or no. Are they going to pay or aren't they? In Oracle, we need a unique key, and so every record has got a unique key, and that's called the RAT-REFNO in this case. So that's our link to our training set, and then we link to our 20% set. And Oracle spots that that's a test set, so it's clever enough to put the word test on it, although the word test disappears subsequently. Okay, so we now right mouse on that and run it. And then that sits and starts to run. It's now marked the build and the test. And then it's running. Now it's complete. So and we can look at the test results. So that isn't why I'm doing this. But if we look at the test results, we can see things like the overall accuracy, predictive confidence. It's not brilliant, this. And I'll explain why later. We can also look at view the models. In this case, this DT137. And here's quite an old, dated way of showing this, and I've always found this quite frustrating because you'd be looking through here, looking for the node that's got the most support and the most confidence, and it's not easy to use. I've just highlighted one here. This one I've highlighted. This is somebody who pays by direct debit, and that in the UK is a bank transfer method, so it's almost guaranteed money as long as there's money in the bank, and so this has got a very high confidence. But if you look here, and it's also got quite high support. There's 10,000 records that meet that rule, so that's quite good. But that's not why I'm here. What we're here for, is to notice this deploy step. So if we deploy and say the selected node and the dependent nodes, we get this screen. It then generates the script, and when we look in the file system, we can see it creates these files. It creates one for dropping the model. It creates a PNG of the actual worksheet. But the important, useful one is the class build script. Now that class build looks like this. And this is the exact technology you need to know to build this in the cloud. And interestingly, Oracle here defaults this parameter to on. This is class weights balanced. That is not a default parameter. That will default to off. So if we run this without any parameters in the cloud, that will default to off. But it's useful to know. These other ones, these are the defaults. So we don't need to know these. We can just take the defaults. And here we can see it's doing a classification model. This is where it brings in my unique key and my target. Okay, so let's get into the cloud. So I'm now going to show you the same model in the Oracle Autonomous Data Warehouse. Now, honestly, when I first used an ADW database, this particular one's the base data, there's 20 million rows. And when I said select count from my table and it came back in less than a second, I was just blown away. It's a great environment, and I use it as almost a sandbox. Okay. Oh, just one more thing I want to explain as well. The model I'm going to show you is based on a 3.1 million record training set. So the 80% has got 3.1 million records in it, but 91% of those are going to pay next month, which sounds amazing. And machine learning is not a science. It's an art, because that 91% of the people, so there's only 9% who won't pay. That is going to cause us bias. And so what we really want, we want low bias and low variance. We want the car to drive straight down the road, and the left-hand side of the road is the correct side to drive on, Charlie. In America, they've got it wrong.
Yeah.
But if we've got a high bias where most people will pay their rent, the car's going to go straight, but it's going to go down the sidewalk. Now, I'll explain variance in a moment when we get to the model. So we need to do something about that bias in our data. And that's what the balance, turning the balance parameter on does. Now, and just the last thing on this slide, here's the data, here's the the Autonomous Data Warehouse database I'm using. And look, I'm only using 2 CPUs. I usually just use 1. I thought I'd go 1 more for luck. And I'm only using 1 terabyte of storage. So let's go and find it online. Okay, this is the same models. I'm starting to build it in the ADW, and I'm going to classify will pay, won't pay. Now, won't pay, the minority classification, this one here, the 9%. That's what I'm interested in. I'm not interested in the 91%. And if you think about it, if I design a model that predicts everybody's going to pay, I would be 91% accurate, and everyone would say, "Oh, that's great," but it isn't. We need to work on the 9%. Here's confirmation that this file's got nearly, well, it's got nearly 4 million records in it. And let me just drop down. This is some of the things that's in there. There's the RefNo. There we've got the balance, various things, features which took a long time to engineer. So here's the, oh, and that's somebody paying their rent into a rubber face. Here's the, I better hide that for a moment. It's just going to distract you. That is that code that we saw on the deploy step from Data Miner. I'm just going for the basic parameters. I'm letting everything default, but I'm making sure that the weights balance is on. And I'm going to run a decision tree. So let's run it. So that's running now. Let's just check that the CPU is working properly. Yeah, that looks like okay. And what about this bit? I think we need to check that as well. Yeah, that seems to be running okay. I hope people do recognise this. It was a great film. I heartily recommend it. One of Leslie Nielsen's best, and it wasn't a comedy. Okay, so I'll just hide that a second. We're running a decision tree here, but what I also want to show you is we've moved on. 18C, we've got a random forest. So let's have a look at this one here. Exactly the same setup, but it's got one more parameter. I'm going to ask for 10 trees. A random forest is the same as a decision tree, but we have multiple trees. So here we're going to have 10. It's Oracle's first ensemble. Now, what's an ensemble? Well, if you think of a decision tree as the old parable of the blind men and the elephant, the decision tree is like having one blind man trying to work out what he's feeling. Now, that's where the variance comes in. If you've only got one person, like the decision tree, you're liable to, one feature is liable to make you think that maybe you've found a plum tree and not an elephant. So with a random forest, it's like employing a load more blind men to feel the same elephant. And at the end of the process, they all take a vote, and they're more likely to work out that they found an elephant and the variance in what they're feeling. And I'm just going to run this one as well. So I'm going to run the random forest. The variance is going to be lower because they'll take a vote. Just a quick example I saw on the net. There was an example of getting pigeons to peck at pictures of a medical problem, and the pigeons were about 90% accurate on pecking the pictures with this problem. But there was one stupid pigeon. I
saw that somewhere. That was great.
Sorry, Charlie.
I saw that same thing about the pigeons. I saw that. That was a good story.
Yeah, because one of the stupid pigeons never got it right. But when they all took a vote, the accuracy was higher because the one pigeon that didn't get it, his vote wasn't counted. So that's the beauty of an ensemble. So, and you see here, both of these models, that took 43 seconds on 3 million rows, that took 39 seconds. So let me see how's the time going. Right, okay. So now we've got these two models. So we've got this rent P1, which is the decision tree, and we've got this rent P1 RF. I'm going to apply the decision tree to my 80% and my 20%. The model never saw the 20%. And I'm going to do the same. I'm not going to run all of these because you can see that runs in 1 minute 54 seconds. So I'm just going to show you what we've seen, what I've already run. What this is it's important though to run it against the data set that the model was used against. Can you see we've got a slightly higher accuracy on the data that it saw opposed to the data that it didn't see? But we haven't got much of a drop, which suggests that the model is good at generalizing because the overall accuracy didn't drop on the data it didn't see. And when we look at the random forest, we can see the same pattern. But the random forest overall accuracy is actually lower than the decision tree. Well, that isn't strictly true, as we'll find out in a moment. Because remember, this is the overall accuracy. How many did we get right? We were expecting to get a lot of the Ys right, but the proof of the pudding is on how many of the won't pays we got right. So we can use Oracle to generate, well, in fact, I'll just quickly show you what the code behind this is. Here's the apply to the two data sets, and here's the calculation of the confusion matrix. So let's shut that down again. So here we have. So here's what we're interested in. We're interested in predicting won't pay. Now, when I've done this model before I put the balancing in, the recall was terrible, but the accuracy on will pay was really, really good. Now, we still haven't got a great precision, but we've got quite good recall here on won't pay, and that's what I was aiming at. So you can see that this is the confusion matrix for the data the model was built on. This is for the random forest. These two are the random forest. These two are the decision tree. We go down here. I've also done a rock curve. Now you can see the rock curve, the area underneath the curve. So a perfect prediction, the area under the curve would be 100%. Now this is 0.85, so it's 85%. But here we're starting to see an interesting, the random forest has done better. It's done better. The area is greater, therefore the predictability, the ability to predict is better on the random forest. Let's go down. Here's some lift. So this is the code we need to generate a lift chart. So I'm doing a compute lift on the 20% holdback and on the 80% that the model is used. So I'm comparing the lift for the two. I'm doing the same for the random forest, but I'm also doing, this is for the won't pay. These two are for the won't pay. These two are for the will pay. And it generates this. Now, I like this. We can now compare the decision tree directly to the random forest. And what this is telling me, if we look at this here, it's saying that, well, if you think 100% represents you going to all those 30,000 properties, knocking on the door and saying, are you okay? Are you going to pay your rent next month? Now that would be quite costly. Well, sorry, all the people that you predict are not going to pay. Sorry, the 100% represents that. But what this lift curve is telling us is that if we say here, we can see that if we just go and knock on the door of 37% of our prediction, we're going to hit in the decision tree 83% of all the people who won't pay next month. But the random forest does better. It's 88%. So we will hit 88%. So what we can do, if we haven't got much time this week to look at everybody, we know that as long as we get through 40% of the data, we're going to hit almost 90% of the people that we predict will not pay. So it's a useful indication of the power of the prediction. And here you can see the very poor lift curve for the Y, because you literally have to go through everybody who you think are going to pay before you hit the 100%. It's like a straight line. But remember, it's important to us that we get the people who won't pay. And what's happened by using the balance parameter, Oracle has generated a cost matrix, and it's applying a cost to the won't pay to increase the likelihood of their prediction. Okay, so if we look at the confusion matrix as a bar chart, they all look pretty similar. But the important thing here, so this is what getting everything right looks like. This is what we did. But the important thing is that's how many we got wrong for the will pay, won't pay. It starts to get confusing after a while. Now, the last thing, the ability to do these kind of charts is pretty good in the Zeppelin notebook, but it's not on a par to what we can do in the analytics cloud. So I'm going to move to that in a second. But the last thing I'll show you, if we look at the raw decision tree model, remember the random forest generated 10 trees, so we can't easily look at that. We're starting to get into black box territory, and in government, we really need to be able to explain why and why the model has made the prediction it has. So the overall position on these 3.1 million records is 99, well, nearly 91% will pay and 9.34 won't pay. Remember, this is the 80% block, so that isn't surprising to us. I managed to generate this. I think it is quite useful to follow. The blue is the won't pay, the orange is the will pay. And we can, this bottom thing here, you can't see the axis, but you can when you hover over them. And you can see that the dark is, the overall height of that is the support. So that's how many records meet this rule. And the dark orange is how many got correct. So what that's saying is that there's a 94% chance that they will pay if their balance is less than 1. So basically people who are who've paid their rent up or are in credit, they're 94% likely to pay next month in total. And here we've got some of the rules. But I don't really want to show you that. I want to show you what we can do in OAC now. So if I go back to here. So let's visualize it in Oracle Analytics Cloud. And this is a great thing that I spot on the greatest value of a picture is when it forces us to notice what we never expected to see. And right at the end, I'll show you something I didn't expect to see, which OAC really drew out for me. And another reference to Tesla. It is like autopilot for your data.
Hey, Bill. Barry. There's a question here from Kenny in Kansas that wants to know if you actually do have a Tesla car.
I might have.
Yeah. And I thought for those who may not know, Tukey, you want to explain what his most famous, how we all know him, if you don't know the name?
No.
Napoleon.
Oh.
Napoleon's March.
Oh.
I thought that was what everyone would know him by. Maybe it's just me. But if you Google Tukey and you see Napoleon's March, he did a great graphic that does exactly what the quote is explaining. But sorry for interrupting.
Yes, certainly, yes. Of course. Sorry. Yes, of course. The with the troops moving.
Yeah,
I always love that. That's for people that like visualization. That's great.
I did this. I was up really late doing this, and I saw that, and I thought I recognized that name. Yes, sorry, you've completely blown my flow here. Then no, it's just
Sorry,
right.
My apologies.
No, that's okay. Let's go. Let's go back.
You're doing far too well.
Right. Okay. Here's what we can do in the Zeppelin notebooks. Well, right. Let's have a look at what we can do in OAC. So. I've visualized the same data that we just saw, but I've put it into OAC, and I've asked for here. It's let me just click in it. Okay, I've drawn it as a tree diagram. So this is the overall tree that you just saw in orange and blue. So let's improve it. let's look at support. Let's size each limb by the support. And immediately we can see that there's more support for these rules here. Well, let's improve it a little bit more. Let's take the percentage, let's put that as color. It's gone darker, so we can see that a 99% certainty is dark blue. So not only have we got support, high support here, we've got some useful indication that these are good rules. So what can we do more? Well, we can do more. Let's break this tree into yes, no. So will they pay, won't they pay? So I just trellis the column. And now I can see that there's less rules for won't pay than there are for will pay. Now I can further do things like I could do here, I could search for people who pay by bank draft. Okay, and then select all of those. And we immediately see there aren't any people in this model that won't pay, that don't pay by direct debit, if you see the negative. If you pay by direct debit, you're going to pay your rent in this model. You're going to pay your rent next month. So let's just clear that back a second. I'll just clear that, clear the filter selection. So what the last thing I'll do before I just click one of these. Oh, let's just look at ones where we're pretty certain. So let's look at ones where we're 88% certain. And now we've got something that's a bit easier to follow. We've still got this strong rule here. So what is that strong rule? When we click, well, it's highlighted this one here, but that's not quite what we want. So what we'll do, we will use this as a filter. And now if I click on that one there, we see it filters this back. So basically, this is somebody who pays by direct debit, they're in credit, their rate of change is either going down or flat. So this is a good payer. This is somebody who we really do not need to bother with. This person's going to pay their rent next month. And there's 700,000 records that back this up. That's why it's 99% certain. But let's have a look on the won't pay side. We haven't got strong stuff on the won't pay. Well, we already knew that. So let's have a look at 37. Well, this is somebody who owes us more than 7 weeks rent, and it happens to be less than or equal to 18 weeks. So once you owe more than 7 weeks rent, the likelihood of you paying 4 weeks rent in the next 5 weeks is 90%. So you could probably have guessed that. We haven't got a great deal of support, but as I said, this data is 9%, 99% won't pay, and 91% will pay. So let's look at some of the other things. Well, do you remember the rock curve, the lift curve? I've put them all into a visual here to help me understand the difference between the decision tree and the random forest. And this is the difference between the two. So we can see that the random forest here, actual won't pay and won't pay. We've increased our hit rate of 4,200 extra records predicted correctly that they won't pay. And that is what the balance did. It reduced the variance. It reduced the variance on the prediction of won't pay. This is us trying to keep the car on the road. So that has been successful for this random forest. We can see that the overall accuracy actually went down on the random forest. But look at the recall. The recall for won't pay went up by 5.74% on the random forest. So the random forest for our won't pay, and you can see that with the rock curve as well. The green and blue is the thing that isn't a random forest, the decision tree, and that's why the area underneath the random forest is greater, because it's a more accurate model. There's the lift as well. The yellow and the red, that's the 20% and the 80%. The 80% set, remember, is the prediction is going to be better because the model saw the 80%. The model didn't see the 20%, and that's why the 20% is slightly less, but it's within 5%. So it suggests the model generalizes well on unseen data. So that's good. And a couple of other ideas I had for looking at this. This is an attempt to show prediction boundaries. So I've thrown my features, and I've compared each feature against itself. So this is average balance against age, that's average rate against age, that's confidence against age. So we can see that there's interesting patterns are starting. So if we look at this one, for instance, I don't click the bubble to refresh the data. I knew that it would go. Yeah, when I was waiting to come on, I was thinking, I hope it doesn't time out. Okay, so what this is showing me is I've got age running up here. We've actually got some 97-year-old people in this database. So you can see that as age increases, it has no effect on the prediction of won't pay. But as our debt increases, so this is our average balance. So if they owe 1 to 3 weeks worth of rent, the prediction that the probability they won't pay is 0.12. As we go across, the probability increases. So that there's obviously a boundary here of about 6 to 8 weeks, and we saw that before in the elephant decision tree. Is that as there comes a point where you owe a sufficient amount to almost guarantee that you're not going to pay your rent. And so doing this with the different features can be useful. And if age had an effect, we would have seen a rather interesting heat map here with age changing and prediction changing. So I thought this was quite useful. If we have a look at a prediction scatter as well, I was fed up of our friends who use Python and R throwing up a scatter so I thought I'll try and do it. And it's not that hard to do. So here, we've got age and confidence, we've got age and pay frequency. We can see here that pay frequency and pay perk is how often, well, it's a percentage representing how well you've paid over time. And pay frequency is how often do you come in and pay. So you can see that there is possibly a binomial. There's a negative correlation between those two, and it almost looks like a slope, like a curve. But what's interesting about these, of course, a decision tree is immune to multicollinearity. But if we were, say, using a regression model here, this is not what you'd want to see. You would not want to have these features or one or the other of these features in your model. But a decision tree is immune to this. But what I noticed, the green are where we got the prediction right, but the red is where we got the prediction wrong. And what I'm noticing is this red pimple is in this data all over the place, this same set of data. So we can see that on low pay frequencies and on low percentage of payment, we're getting it wrong, but we're getting a lot right here. So I'm starting to get a little bit suspicious about where this has come from. So what I decided to do is let's have a look at the accuracy of this model over time. And what I found was there's a big dip in it. I'm showing here the random forest, and I'm showing the decision tree. I mean, you can see the decision tree is. Let's just. I'm feeling lucky. Let's put that a little bit bigger. We can see here that overall, so this is yes and no predictions, the random forest is lower. The prediction is lower, but we know that it gets the Y's wrong. Okay, and the decision tree is better. But boy, oh boy, something went wrong on the 11th of March. So let's come back to that. I've asked Oracle. I didn't write these. This is another part of OAC. I just asked Oracle to put this chart into English, and it's noticed that it's seen a 0.54 rise compared to its initial value on accuracy across the range here. But it's not. Let's see. One of them here. If we look down here, I always struggle to spot the bit where it mentions 11th of March. September, right? Yes, here. So this is looking at the accuracy for will pay, and this is looking for the accuracy for won't pay. And can you see it spots, it says the measure plunged on the 11th of March. Now, that when you look at these two things, when you look at will pay, won't pay, but just for the random forest, you can see that the 11th of March event only happened for the won't pay prediction. It didn't happen for the will pay. The will pay happened on the 15th of April, which is interesting because that's 5 weeks in the future from the 11th of March. So one model got damaged early, the other model damaged later. So, well, how could that have happened? Well, let's have a look. When we look at the payments made in our training data, we see this spike. And when we ask Oracle to put this into words, Oracle spotted some interesting things. It saw this drop on the 15th of April. So the average, this is like a normal bounds for about 92 to about 2. So the average amount paid is within bounds for most of the year. There's something odd went wrong here. We didn't spot that one. But here, the average payment on the 15th of April, well, it dropped down to basically 0. And guess what happened? Somebody failed to load the cache file. So our models really couldn't have predicted, our model here really couldn't have predicted that in 5 weeks' time, an operator would fail to load that file and that nobody received a payment. So the won't pay got it wrong because effectively nobody paid in 5 weeks' time from that date. Now, there's lots of things that this is showing me. It's showing me that this range, these 5 weeks, we need to take that out of our data because it's causing that pimple in the data. It's damaging our model. Another interesting thing is that the won't pay is slowly increasing, and the will pay, the won't pay accuracy is slowly increasing, and the won't pay is slowly decreasing. And this is a measure in the UK of the effect of universal credit. There is a drop in payment, and if we look back on what happened, we can see that Oracle spots that for the 2 years that we're looking at, there's been a 15% drop compared to the start of the period in average payment, and that's an effect of universal credit. I'm confident that is.
Hey Barry, could for those of us not in the UK, could you just briefly explain the universal credits concept?
Universal credit is up until last year or the couple of years before, the people on benefits received, the landlord of their property received each month the money they need to pay their rent. But in the last few years, universal credit has replaced that, and the money is sent directly to the tenant. But it's also, when they claim, it can take 5 weeks for them to receive their benefits. So that it can mean that it takes a while for them to get back into the flow, also when they receive this money in 5 weeks' time, there might be other priorities. So it's been responsible for a lot of for a loss of rental income in the UK. Obviously, the data I'm showing you as well stops at June. I think we would see a far bigger difference now with the effect of COVID. Universal credit is the main factor here. And let's just go back to my slides. So that's basically it. But I said, well, what when we do have an accurate working model, and as I said, the model I've just shown you today is the start of it. It needs more work. We need to look at the costs. We need to try and get the bias to move ourselves more onto a straight road. We need to try and mitigate the variance, and maybe we may even need to engineer some more features. But when we do have that accurate model and the other models that we've done, what do we do it? Well, we surface them in our integrated housing management system, and we're bang on Apex 20.1 now. We upgraded at the start of this year. We're very proud of that. Our management system covers multiple areas. but what I've shown you today has an effect in the helping for the people renting council houses in the UK. And the main thing is that with this extra insight, our customers can use as a whole all these different predictions, and seeing their own data, they can use it as a whole to actually try and help the customers before they get too much into trouble. Because as we saw in one of those models, once you get more than 6 or 7 weeks worth into arrears, it's very difficult to claw it back. And the cost of dealing with that situation in extra letters, in extra work, and the awful thing that will happen eventually where you have to possibly evict somebody, that's immensely expensive. And we really want to keep people and look after them and see if we can help them before they get into debt. So being able to predict that someone's not going to quite pay all of their rent in the next 5 weeks is going to be really useful, but it's not the only model that we should use. So just a quick show of one of our Apex screens. This is an example of a set of people that we've brought up because we believe well, in fact, the first 3 people have missed a payment we expected, but these could have been selected on the basis that they won't pay, and then we can dive into that data, and because it's Apex, we can display that data on any tablet or mobile phone. We're using Jet reports, Jet charting as well, linked into Apex, which is like native into Apex. So we're really, really, really pleased with this. Yeah, that's.
Hey, Phil, who uses this? For the reporting and such. How many? What are they, managers? Who uses it?
Well, the screens I've just shown you, Charlie. This is a frontline member of staff who's out there in the field helping people with their rent arrears. We've also designed screens around this, which is like a management view, Charlie, where you can look at the high level and see where the debt is across your organisation by estates and patches, and so there's 2 sides to it. There's a management side, again using Jet to surface some of the visuals for that, but the power of interactive reporting in Apex, the ability to customize that and to download it into a spreadsheet, or to say I want an email of this data every Monday, so you can have your team load, and that can be emails you every Monday with your new cases. It's really powerful. I love Apex. I think it's our system's got something like 3,000 pages in it. This is just the rent side of managing people's rent. We've got things to do with assets, asbestos, and managing people applying for a homeless. People applying from a homeless position or wanted to move to a property. All sorts, Charlie. It's a massive application. We've designed it back probably 25 years ago, 30 years ago when I started here, and it's marched on from Oracle 1.1 to Oracle 3 forms, Oracle 4.5 client server forms, Oracle forms 10 through to the early V6 Apex, and right the way through to Apex 2.1. It's a really.
I'll have to ping you later to help me with something I'm struggling with. This is good.
So there you go. That's I think I'm on time. Is that okay, Charlie?
You're perfectly on time. We have a few questions here. One says, fantastic presentation. Thank you for sharing. And I agree with that. Another one says, this is earlier on. You were showing the rule field populated, I think in OAC was where about when the question asked. And the question was the rule field populated by the decision tree output or the random forest output? I think it was decision tree, correct?
It was the decision tree, yes, because it's taken me about a week or more to do this presentation, and to actually decipher and pull apart the random forest set of 10, it was just too much work. It would be possible. But now Roger and I are going to talk a little bit later on. I think I know the answer, which is going to be no, but we have a growing Oracle analytics and data GitHub community.
where you can post and share things. So if you have a cool demo or some cool code or whatever, this is all sort of too proprietary for you to share any of that kind of stuff, or is there any parts of this that you could share?
I'll think about that outside this with you. Yeah,
because you've done so many cool things. And I mean, guys, I don't know about you, but I mean, I loved what Barry did here. And in fact, you know, I work at Oracle. I'm supposed to know this stuff. But that's the first time I guess I kind of realized you could even put videos in the Oracle machine learning notebooks, which I just loved. And now I have videos in my notebooks, Barry, as of like 5 minutes after I saw you doing it. And that is the idea of this community, is to sort of share best practices, stuff like that. So, you know, wonderful job. Roger, you checking the questions? Are there any other? I saw one about features in the database. I can take that one offline.
Yeah.
Anything else, guys? Such a great presentation. We're going to be. If you
don't
ask me a good question, you're going to get Roger and I sort of tap dancing with trivia questions and fun and games until we come on in about 13 more minutes at the top of the hour with Philippe. So now's your chance to ask a true expert on, you know, you've seen it all. You've seen the database, the machine learning in the database, the OAC. He ends up with the Apex, and even the mobile Apexes. You know, that's kind of, at least I think, what we all see the future of putting this stuff together. So any more questions on that?
No, that was really excellent, Barry. It was interesting. In a long time ago, I did a lot of work with Broomley Housing Association, which I think morphed into something else after that. And actually, if we'd had some of these tools available, I think it would have made our lives a lot easier. It's fantastic.
Yeah, thank you.
Also, guys, just so you know, there's a bunch of us on the call here. It looks like quite a few, so that's great. Thank you. Also, the Slack channel is intended. We don't know if it's going to work, but we hope it works. So if you have any questions, I guess you could say at, you know, Barry, because he'll be in there somewhere. You could say, hey, at Barry, how do you do this, or what happens there, or whatever. So that's the whole idea of setting that thing up.
I should have to log on to it.
Yeah. Oh, you didn't join yet. You got to join. It's no charge. No charge. I thought I had other questions. I was logging down here, but went through it so much to absorb there. I swear I had another question for you here somewhere along the way.
You say you're going to answer the neural network one later.
Yeah, I mean, the convolutional neural networks, no, we don't, you know, sort of go fish on that. We do have some stuff that's coming in our in our services, Oracle Machine Learning services that are coming out. So, you know, hopefully the end of this month, we'll have a little bit more on that. More in the area of sentiment analysis there, using the ESA models and such in there. But you know, I liked what one of our leaders had said once, that Juan Loaiza had said that what we do is, at Oracle, we do business machine learning, you know, not all the esoteric. Not that it's a bad thing to do, but we're not really good, at least at the moment, of doing all sorts of.
There's another question here as well, by the way.
Yeah, facial recognition, all sorts of, you know, image and analytics. We have some of that that's embedded in other Oracle applications, but for the end consumer, that's still something that I guess is not what we're making available today. What's the next question, Roger?
Sorry, I didn't mean to hack you. Shows our great professional approach. Tim Lammers says, given the power of one variable of delayed payment, which may be obvious, does it make sense to run models eliminating that variable in order to see what else might stand out that would be predictive?
Yeah, there isn't. That's a tricky question. There is a lot more to this. To be honest, I started out using unsupervised k-means clustering to drive this, and that answered a lot of these questions, and it also drove me to have to create some more features, because when the more you look, the more interesting things you find, and the crisp DM was mentioned. It's this cycle of doing one thing and then trying another thing and then cycling back and trying it again. There's lots of things that could be done. I'd like to have a go at oversampling to try and oversample the won't pays to see if that will improve. But that's a bit more of a challenge in Oracle, because you need this unique key for the record. So I could generate one. You
don't have to have a unique key. It's advised to have a unique key. Yeah. It
But
will. It's performance kind of thing, and I run it every now and then when I do bad things. I remove the unique identifier, and it will run without it, but it's not advised.
It does drive a lot of my predictions and a lot of my joins later, so it is useful to have that unique key.
It's just good data, good machine learning, data hygiene kind of stuff. I think more than anything else, it is an interesting thing. I know sometimes in this area, you look for one variable and then you say, well, if I don't have a variable, what would other variables be? And you can imagine a whole slew of them. But if you have the variable you want, you're good in so many ways, right?
It would be interesting to build a model on just the one page and see if they broke down further. I think I would tackle it first with unsupervised, and I'd look to see. I use a PCA primary component analysis.
Yeah.
To work out which features were the most important for say, and try and work out what the optimum number of clusters would be on just the won't pay, and see how many sets of distinct data have I got in that one classification, and that might then give us some ideas of whether it's worthwhile doing a classification on that. So
there is another feature. I think we covered it one time, but in the I think it was 18C, we added this Kolbeck-Leibler divergence thing. It's most easily, you can do it, guys like Barry, and I struggle with it, but I can do it, with a little bit more code typing. You can use it just purely in the code in the database and in the notebooks and such. But in the GUI, in the Oracle Data Miner GUI, when you do the attribute importance, when it asks you what's your target field, and if you say pays on time, yes or no, if you remove that and say I don't have a target field, what it does is it does a expectation maximization clustering, finding all the different variables that are used to find any kind of information gain in there. And then if you check off find dependencies for each variable that you use, each attribute that you use, it'll also find the correlation. So to the earlier question, like could you find what other things are, you could just check that if you're using the graphical user interface, you just check that off and do that.
I realize that, Charlie. That's a really good tip. Thank you. I'd like to I'll have a play with that.
Yeah, that's a cool feature. I mean, there's just so many directions you can go with analysis. It's hard to cover them all in the amount of time. I think we should probably start to transition over. Are there any other more questions here?
There is one more, which is more sort of general, and it's Mike State is asking, is there a getting started to accomplish something like this? I assume it's several to the point of analytics, machine learning.
Yeah, can I just share maybe I can just share my desktop for a minute here. I will paste this into maybe if we have more time later on, I can cover some of this stuff. But somewhere in here, I have some slides that I'll come back to. I guess I'll just post these maybe in the Slack channel. But what is Oracle Machine Learning? It's free. What are the algorithms? There they are. I'll just post that in there, kind of a visual of what it is. And at the very end, I'll post this in the chat when Philippe starts, and in the Analytics Data Summit thing. So there's so down here is a bunch of hands-on labs and workshops, and there's a bunch of different things out there. So hopefully that started. I do have to say that I remember, I think when Barry was kind of starting out on this stuff, or at least he first came onto my radar, and I got to say he's come a long way. He fits with my example of somebody that knows the database technology really, really well. And because of that depth of knowledge and all the different things that are going on there, it's sort of easier, I'm going to say easy because you've done such a great job, for him to incrementally add machine learning to his repertoire. Or maybe he's always done it, but now he's doing it with Oracle, and it's impressive, the combination of all those skills.
Yeah, definitely. Yeah.
All right, well, I guess we'll go ahead, Barry. Yes.
I was going to say, I did mention in the slides, when you go into the Zeppelin notebooks, Charlie has done about 10 examples, one for each, a regression, a classification, and they are very good. Please read them. There's some, because now and again, Charlie updates them, and there's some nice little techniques in there. There's one for bringing out the rules. So have a look at those. That's a great place to start.
I've had some help on some of those. I think the rules one was I believe Marcos Haransabia, if he's on the call. I think he wrote that little bit of code. Don't think I'm that good at all that kind of code. But yeah, I think the examples, some of my favorite customer references are one where they basically just take an example notebook, export it out of the sample examples, because those are read only, import it into their own space, and then just change the data tables and press go. And if you're able to share any of your stuff that you did, even if you remove the data and everything Barry, you did so many cool tricks in your notebooks. It'd be great if you share those up in the GitHub. With that, I think we're gonna do the crossover. You're gonna get Roger and I doing a couple of things for 5 minutes or less here, and then we're gonna turn it on to Philippe. So a round of applause for Barry.
Very good.
You don't know how to do this in technology yet, so we're working on it, guys. But thank you.
Thank you very much. I'm glad
I see Philippe is on already. Lovely to see you, Philippe, as well. Thanks, Barry. That was phenomenal.
Philippe, hello, welcome.